Good morning. Which side I will get the reply? Good morning, good morning. Okay, one side I got. Okay. So Meghna, Tanuj, am I audible? I think same number are the online as well as in the app, I think. Because number is same. Okay. But their number is increasing. Okay. Okay. So sorry for the delay today. It become late little bit. Okay. So 2 exam over. So last class in the evening, sir, my app is not working, sir. Okay, you can talk to the Prasad, sir. You cannot see the class. Okay, once talk to the Prasad, sir. Okay. So last class I discussed about the mixing of the ice and the water. Sir, no video. Video is coming. Mokshika, maybe network issue, some problem is there due to the rain. Okay, so first we will do some whatever the problem remaining in the calorimetry. First we will complete it. Okay, then we will come to the next chapter. Coming, sir. Okay. So one thing I said, when we are mixing the ice and water, then how to find the final temperature? It is possible that whole ice is not melted. Whole ice is not melted. We are mixing the ice and water. Whole ice is not melted. Then final temperature will be 0 degrees C. Okay. That in the last class I discussed. Okay. In short, suppose you only want to find the, please explain latent heat quotient graph from the paper. Latent heat quotient, Mokshika, that I think you are talking about that quotient. I think something like that. It has given A and B. This question you are talking about. Tell fast. Okay, who has the problem in the app? They can once talk to the Prasad. Then okay. Okay, so here they ask the what is the ratio of the latent heat of the A and B, and on the x-axis I gave the time on the x-axis, and okay, and y-axis temperature given. Okay, and it has given what they are heating at a constant rate also given same. Okay, then they are asking what is the ratio of the latent heat. So we know that Q is equal to ml for the state change. These are the state change. Okay, when parallel straight line means it shows the state change. Then Q is equal to ml. Q I can write power into time. Power into time is equal to ml. They given the equal mass and same power we are heating. So equal mass means mass constant, and power also given same, so P constant. Then I can say what? T directly proportional to L. Means time is directly proportional to latent heat. Now ratio of the latent heat will be equal to the ratio of the time. So LA by LB will be equal to, here I think this time given here to here, time is the 4, and here to here time is the 3. Then TA by TB you will get 4:3, something like that. Specific heat of the solid state, you mugged up according to the Satya, you mugged up according to the like ice and water, but you have to see the graph. If you see the graph what I gave in that paste paper, I think you are talking about, So when you see the graph, slope of the liquid state is coming more. You can check the delta. Slope is the tan theta. Tan theta is the opposite side upon adjacent side. If you find the okay, so tan theta after finding the slope of the liquid state you are getting more. And I said what? Slope is inversely proportional to the heat capacity, or slope is the inversely proportional to the S. Slope more, specific heat will be less. So directly you cannot go to the concept means okay, they given the ice and water, then we can say according to the slope you have to go. Okay, so slope you can see that slope in the liquid state is given more. You can find the value also. Slope is more, specific heat will be less. Okay. Okay, now what I said, if ice and water is mixing and they are asking the final temperature, only final temperature required. They are not asking how much ice remain in the mixture or okay how much ice will melt. So in shortcut, like to check the final temperature is 0 or more than 0, what we can do? Suppose mass of ice I am giving Mi and at 0 degree C, and mass of water theta degree C, that at theta degree C, and that mass I am taking the MW. Okay, so mass of water I am taking MW and mass of the ice I am taking Mi. If you have to find the only temperature, what is the final mixture temperature? So calculate the two product. Okay, first calculate Mi into AT, because how much heat required for complete melting of ice. Okay, so then Mi into AT. If this quantity is greater than or equal to MW into theta, what is the temperature change for the water? Suppose final temperature is 0. So final temperature is 0. So hot water will its temperature will change from theta to 0. So what is the delta theta for the hot water? Theta minus 0. Okay. So if the final temperature is 0, then how much heat ice required to melt? That is what? Mi into AT. And how much heat the hot water will give? Ms delta theta. Ms delta theta means MW. S we are taking 1. Delta theta is what? Delta theta is the theta minus 0. If Mi into AT is more than or equal to MW into theta, then we can say then final temperature will be 0 degree C. Then final temperature will be 0 degree C. Why? Because ice require more heat to melt. Ice require more heat to melt. Then here more heat required. Then what will happen? Completely ice will not melt. Then final temperature will be 0 degree C. So if only temperature we have to find, so by this we can check the final temperature will be 0 or more than 0. So what we will do, we will find the product of the Mi and AT, and we will find the product of the MW and the theta. Okay, if this Mi into AT is greater than or equal to MW theta, then we can say final temperature will be 0 degree C. Okay, exactly equal you are getting, then we can say what? Completely ice will melt completely, and final temperature will be 0 degree C. So when you are getting Mi into AT is equal to MW into theta, then we can say completely ice will melt. Understood or not? And the final temperature will be 0 degree C. Okay, if this product is coming less than the MW theta, it means then you have to go to the what? Suppose final common temperature is this, and then you have to solve accordingly what I said in the class. Okay, same way now you will say by using common sense and whatever condition I write, same type of situation we can get when we are mixing the water and the steam. Okay, water and steam. Suppose water is at theta degree C and steam temperature we are taking what? 100 degree C. So mass of steam I am taking and water temperature is Now, by using your common sense, you will say, if what I said, I'm mixing the ice and, steam and water. Steam and water is mixed. So in the case of ice and water, either the final temperature will be 0 or more than 0. In the case of steam and water, what is the possibility? Final temperature can be 100 because whole steam will not get condensed, then final temperature will be 100 or less than 100. Okay, if whole steam will get condensed, then maybe it can come less than 100. So in that case, 0, ice and water, 0 or more than 0. Here 100 or less than 100. Okay. So who will say how to check that final temperature will be 100 if I am mixing the steam and the water, and how we can check final temperature will be 100? Tell fast. How we can check that final temperature will be 100 degrees C? How we can check that final temperature is 100 degrees C? Tell fast. I'm mixing the steam and water. Water temperature I gave theta degree C, okay, and I'm mixing with the steam. Either temperature will be 100 or less than 100. How we can check that temperature will be 100 degree C? So same like above, I can say what? If ms into 540. Why? Latent heat of vaporization is what? 540. So ms into 540 is greater than or equal to product. Again, product will find mw, mass of water. And what is the temperature change of water in that case? So water will not go to the 0. Final temperature will be 100, means what is the delta theta for the hot water? 100 minus theta, not theta only, 100 minus theta. Why? It is at theta, water is at theta. Final temperature will be 100, then what is the delta theta for the water? 100 minus theta. In the case of ice and water, final temperature 0, then we are taking the theta minus 0 is equal to theta. But here water is at theta, it will go to the 100. Then what is the delta theta? 100 minus theta. Okay, so similar condition, there we are finding mi into 80 because latent heat is the 80 there. Here we are taking the ms into 540. Okay, there we are taking mw theta because theta is the change of temperature of the water if the final temperature is 0. Here change of temperature will be 100 minus theta if the final temperature is 100. If this quantity is coming more than that, then final temperature is 100 degree C. Everybody got? But suppose this quantity exactly equal is coming, then we can say whole steam will get condensed. Greater coming, then some steam will remain in the mixture. Okay. And less coming, it means temperature will be between 0 to 100. Everybody got? Completed? Okay, similarly, suppose I am mixing the ice and steam. Now ice water, steam water completed. I am mixing the ice and the steam. Okay, so one thing, ice and steam, if they are mixing, so two state change will be there, temperature change will be there. Okay, then question will be lengthy if they are mixing directly. Okay, so maybe they can ask the final temperature only. So to check the final temperature, what we will do, suppose they are mixing the ice and steam. So if ice at 0 degree C and steam 100 degree C are mixed, then what we will do first, we will find the ratio. Then if mi by ms, this ratio we will calculate first. Mi by ms, mass of ice upon mass of steam. If this ratio is coming greater than or equal to 3, less than or equal to 3 first. Suppose this ratio is less than or equal to 3, then final temperature is then final temperature will be 100 degrees C. So when ice and steam they are mixing, so first we will find the ratio of the mass of ice and the mass of steam. Okay, if this ratio you got less than or equal to 3, then final temperature we can say directly it will be 100 degrees C. Final temperature will be 100 degrees C. Reason is what? First ice will melt Mi into 80. Okay, then it will go from the 0 to the 100 degrees C water, M into 100. So you will get 180 around 180 Mi. 180 Mi and steam will get condensed, it will give 540 into ms. So 18 3s are 54, 18 3s are 54. From that I got this relation. So Mi by ms is less than or equal to 3, less than or equal to 3. Then what we can say, final temperature is 100 degrees C. Everybody getting or not? Okay. Exactly 3 we are getting. It means whole steam will get condensed, means we will have completely water. We will have completely water. If exactly 3 I am getting. Less than 3 I am getting, it means mass of ice is lesser. It means whole steam will not get condensed. So if the less than 3, then we can say the final temperature 100 and some ice will remain in the mixture. Equal to 3, then I can say final temperature is 100, but whole steam will get condensed. This everybody got? If Mi by ms, now if this ratio you are getting greater than or equal to 8, greater than or equal to 8, then final temperature is equal to 0 degrees C. If this ratio you are getting greater than or equal to 8, then we can say final temperature will be 0 degrees C. More than 8, 0 degrees C, some ice will remain. Exactly 8, it means whole ice will melt, whole steam condense, means completely we will have water. Okay, but this ratio is more than 8, then it means the final temperature will be 0 degrees C. Now by this inequality you can see between 3 to 8 we are getting, between 3 to 8 if the ratio we are getting, it means final temperature will be between 0 to 100. 0 to 100 means whole steam will get condensed, whole ice will convert into the water, and the temperature will be between 0 to 100. Like I am getting the ratio is 4. Ratio is 4 means it is a more than 3 and it is a less than 8. It means the final temperature will be between 0 to 100. Okay. Tell fast. Everybody got? Completed? Like fast you will say, suppose I am mixing 1 gram of ice and 1 gram of steam. 1 gram of ice and 1 gram of steam. What is the final temperature? I am mixing 1 gram of ice and 1 gram of steam. What is the final temperature? I am mixing 1 gram of ice and 1 gram of steam. What will be the final temperature? Tell fast. M gram of ice and M gram of steam, then what is the final temperature? 100 degrees C, because Mi by ms. Mi by ms I will get 1. And 1 is less than 3. 1 is less than 3, then final temperature will be 100 degrees C. Now it is a less than 3 I am getting, it means some steam will remain in the mixture. Some steam remain, then you can go to the what method I said. Suppose x gram steam got condensed. So x into 540 is equal to heat taken by the water. Okay, from that you will get the x value. Okay. Suppose I am saying if x gram of ice mixed with y gram of the steam, and we have then x plus y gram of the water at 100 degrees C, then which option is correct? Then which option is correct? X gram of ice mixed with y gram of steam, and finally we have x plus y gram of water at 100 degrees C. Then which option is correct? Answer 2. Okay, everybody got? Reason is what I'm saying, x plus y gram of water, it means I have the completely water, means whole ice converted to the water, whole steam converted to the water. Whole steam got condensed, okay, and we have the temperature 100 degrees C. It means what we can say, mass of ice upon mass of steam will be equal to 3. Then answer will be x is equal to 3y. Everybody got? Okay. So here no need to waste more time in this, because mixing any problem you can do now by if suppose only they are asking the final temperature, by this way we can find. After that, if they are saying the like how much ice remain, how much steam remain, that also you know the method, x gram we have to assume. If the temperature we are getting between 0 to 100, then we have to go to the way, means final temperature theta, then ice will melt ml, then ms delta theta for ice, then steam will condense, then for the steam we will write m into 540 plus ms delta theta. Everybody know the way, or I have to discuss one problem. Okay, so you will try ice mixing and all. One more question. Okay. This is in our module, similar question I am discussing. If 2 liter water at 20 degrees C is heated by electric heater of power 2 kilowatt and its efficiency is 50%. If temperature of water increase up to 60 degrees C and 160 joule per second heat loss in surrounding, then find time taken by heater. Question is what? 2 liter of the water at 20 degrees C, it is heated by the electric heater of the power 2 kilowatt and its efficiency is the 50%. Okay, means maybe some energy of the heater is getting lost due to the internal heating or some radiation loss. After that, whatever the heat it is giving to the water in temperature increase up to the 60 degrees C, and whatever the heat water has taken, in that 160 joule per second heat is lost in the surrounding. Then we have to find the time taken by the heater. Now listen first. What is the power of the heater? Power of the heater is 2 kilowatt. But one thing I gave the efficiency. Efficiency is the 50%, means internal some energy is getting lost, 50% energy is getting lost. So what is the useful power? Useful power is only 50%. Okay. So first, suppose I am saying what is the useful power? That is equal to what? 2 kilowatt means 2000 joule per second into 50% means into 50 by 100 means you will get what? 1000 joule per second. it means useful power will be only 1 kilowatt. Useful directly we can say, but I have just shown, suppose they have not given any percentage, 25%, 75%, how to calculate. Okay, so 50% means directly we can say 1 kilowatt. So this much, this is the useful power. Okay, now if I'm running this heater, so who is taking the heat in this problem? Only heater is giving the heat, and water and surrounding, two are there. Water and surrounding, they are taking the heat. So here heater is giving the heat, water and surrounding is taking the heat, and we know that heat given is equal to ultimately what is the total energy, that we will say heat given is equal to heat taken. Okay, so suppose I am running the heater for the time t second. I am running the heater for the t second. Then how much heat the heater will give? Heat given by heater in t second. Then I can say heat Q is equal to what? Power into time. Okay, power into time. And that is a useful power basically. And who is taking this heat? Water plus surrounding. Water temperature increase from 20 degrees C to the 60 degrees C. Water temperature increase from 20 to 60. Then what is the heat taken by the water? Ms, Mw, Sw, delta theta. Okay. And surrounding also taken the heat. Who will say how much heat taken by the surrounding? How much heat taken by the surrounding? How much heat taken by the surrounding? Tell fast. How much heat surrounding has taken? How much heat surrounding has taken? Anybody? 336 kilojoule. 336. How you got this value? 160 joule. Surrounding total heat, I'm saying, I'm not asking how much per second. So suppose how much time I run the heater, how much time I run the heater t second, and heat is not total heat is not 160 per second, surrounding is taking 160. So whatever the heater is giving, 160 joule per second is going to the surrounding. So if I run the heater for t second, then how much heat will go to the surrounding? 160 T, not 1600. Why 60? I don't know the time now. So that time I have to find. So suppose I am running the heater for the t second. So in 1 second, what is the heat taken by the surrounding? 160. So t second, how much heat it will take? 160 T. Okay. So surrounding heat, what we can say? 160 T. This everybody got or not? Why? Per second. If they are only saying 160 joule heat loss in the surrounding, it means total loss we will consider 160. But 160 joule per second given, it means per second surrounding is taking 160. So t second, how much it will take? 160 T. Okay. Now I am putting the value. 1000 into T, that is equal to mass of water, 2 liter. 2 liter water, what is the mass? 2 liter water mass is a 2 kg. 2 liter water mass is 2 kg. When you buy the water bottle, in that 1 liter 1 kg they written also. And you know water, 1 liter means 10 to the power minus 3 meter cube, and density of water is 10 to the power 3. Ultimately 1 liter will come 1 kg. Okay. So what is the mass of water? 2 kg. What is the SW? What is the SW I will put? SW I will put 4200 because energy I am dealing with joule and the mass I am using in kg. So it means I am following the SI unit. SI unit, then SW I will put 4200 into delta theta. Delta theta for the water is 20 to 60. 20 to 60 means 40 degrees C. Okay. MS delta theta plus 160 T. Up to this everybody got 1000 T minus 160 T, what you will get? 840 T, that is equal to 2 into 4200 into 40. Now 0 0 cancel out, 80 84 5 are 420, 5 to the 10. So T, how much you got? 400 second. So how much time it will take? 400 second. Completed. Okay. Completed. So you have the gym, maybe you have bought the gym material, otherwise when you will get the material, solve the whatever the question given in the one page, like 3-4 question they given on the heater, geyser, efficiency problem. Those are the good question. Solve it. Okay. Completed. Okay, one more question, that is the same module question. They given what? Ice is at -5°C is heated. So finally water and ice remain in mixture. If 1 gram of ice only melted, then that is a m gram ice. Then find m if heat supplied is 420 joule. Why I am discussing this problem? Actually, in this question, specific heat of the ice given 2100 joule per kg degree C. Latent heat of melting of ice also given in the SI unit. So, and here heat supplied for this purpose, how much heat we gave? 420 joule. Okay. So most of the quantity they have given in the SI. Mass of ice they given in the gram. Okay. Now listen. First thing, who will say what is the final temperature of this mixture? So they are saying only 1 gram ice is melted, and in the mixture they are saying some ice and water remain. So we know that till the whole ice will not melt, temperature will be 0°C. Okay, it means what is our final temperature here? 0°C. Okay, so first ice is at -5, it will come to the 0°, and in that only 1 gram of ice will melt. That is the problem. This everybody got or not? So final temperature is what? 0°C. Okay, up to this everybody got. Now listen, we can solve this problem by the only unit is the problem. Okay, so first ice conversion we are writing. So ice -5°C, and what is the mass? M gram. It will convert first, it will go to the melting point. What is the melting point? Then we will have the ice at 0°C and then total M gram. Okay, first whole ice will go from the negative to the 0°. Now here still we are giving the heat, then this ice will melt, then it will convert into the water at 0°C. But here they are saying only 1 gram of ice melted, it means here we have the only 1 gram ice is melted. Everybody got the transformation. First whole ice will go to the melting point. In that only 1 gram of ice will melt because we are giving the heat 420, and according to the data only 1 gram of ice has melted. Everybody got this transformation understood or not? Okay. Now, what I said, according to the unit, they given the specific heat of the ice is the 2100, latent heat they given in the some 10 to the power some order they given. So we have the two options. Okay. In calorimetry problem, when we are writing the heat given is equal to heat taken. Okay. So both side we can use the mixed unit also, like mass I can use in kg, specific heat and latent heat I can use in the calorie per gram. But we have to keep in the mind which quantity, which unit for any quantity I am putting in the left hand side, same I have to put in the right hand side. Like latent heat, specific heat I am putting in calorie per gram. So both side I will put the calorie per gram. Okay. Mass suppose I am putting in kg, then other side also mass I will put in kg. Ultimately when we will equate, then heat given is equal to heat taken, then the common unit will get cancelled out. According to that we will get the answer. Okay. But when we are calculating the total heat required, then we have to follow the one particular unit, because in that case if you are using the mixed unit then you will get the wrong answer. So when we are equating heat given is equal to heat taken, then we can use the mixed unit in both sides. But whatever we are using one side, the same unit we will use the other side for any quantity. Okay. This over. So what I said, this problem we can solve by using SI unit. That is the one option. SI unit means this m gram I will write in the kg, m into 10 to the power minus 3. S I will take what? Specific heat of the ice 2100, delta theta 5, ml latent heat of melting they given in the SI unit 80 into 4200. Like that we can solve. One way is that. Other way what? I will solve in a whole in a calorie per gram unit, and okay, I will convert all into the calorie per gram because those value we know. So if I am solving that, so I am writing the heat required. First, ice temperature is increasing. So it is an increase in temperature of the ice. Then heat, I can say what? M, I'm directly taking gram. Then specific heat of ice I will take 0.5. They given 2100 joule per kg, and that we know it is a 0.5. Okay, calorie per gram. Delta theta for ice is what? 5. Okay, this is the this to this. Okay. Now from here to here only 1 gram ice is melted. 1 gram ice melted, then ml. Ml means 1 gram into L is what? 80. Why? I am using the calorie per gram unit. Okay. This everybody got. So here to here I got, then here to here melting is what? ml. This is equal to what? They said for this we are supplying the heat 420. We are supplying the heat 420. Okay. But 420 they given in joule. 420 they given in joule. Here I am using the calorie. Here I am using the calorie. Then 420 I will divide with 4.2. Then I will directly get in calorie. That you will get what? 100. Okay. Then without changing the more unit, we will get the directly m value in the gram. Okay. Now this what I got 2.5 m. That is equal to 100 minus 80. 100 minus 80 is the 20. So m what I got 200 by 25. That is equal to 8 gram. So what is our m? We got 8 gram. Completed? Okay. Completed? Now next is the triple point curve. For water. So what is a triple point? That already I discussed in the triple point thermometer. So triple point is what? It is a condition of the temperature and pressure at which the three states exist together in the thermal equilibrium. What is a triple point meaning? It is a condition of the temperature and pressure at which we can say all the three states of matter exist in the thermal equilibrium. Okay, everybody got? Okay, so for water, temperature at triple point of water is equal to 0.01 degree C, or we can say 273.16 Kelvin. Why? 273.15 is the zero degree C, but here we are getting 0.01, so that's why 273.16. Okay. And pressure, what we can say? Pressure is equal to 0.006 atm or 611 Pascal. So these are the, like in the NCERT they given the graph for the water triple point. So this value also we have to remember. Triple point temperature is what? 273.16 Kelvin or 0.01 degree C, and the pressure is what? 611 Pascal for the water particularly. Okay. Completed. Okay, now I am making the triple point graph. Okay. Now listen here. This is the triple point curve for the water. Okay. Three different state we have. I have shown temperature. I gave at O is the 273.16 Kelvin, and the pressure is what? 0.006 atm. In the Pascal, it will be 611 Pascal. Now listen. First, one type of question is what? They will give the, suppose this graph, and they will say here which state of matter we will get, which state we will get here, which state we will get here. Like that they can ask. Like here they will ask the state. What I write here: liquid, gas, and solid. So how we can remember? You can remember, like suppose this is a container. In the container we can fill the liquid. Okay. So this means here we have the liquid. So here we are getting liquid. More temperature, then we will have the gas. So here this side gas, and this side we will have the solid. Okay. So this everybody got. Okay, so this states we have to know. One type of question they can ask this. Okay, are everybody getting? Okay, now I have shown the three curve OP, OC, and OA. Okay, so if I ask what is the curve OA, what is the curve OA? Next type of question is what? They can ask the which curve OA represent, which curve OB represent, which curve OC represent. Okay. So if you see the OA, then one side of the OA we have the gas, and one side of the OA we have the solid. One side of the OA is the solid, one side of the OA is the gas. And on the OA it means both will be there in thermal equilibrium. So OA, solid and gas state exist together in the thermal equilibrium. On the curve OA, solid and gas state exist in the thermal equilibrium. Who has a doubt, ask. So what I said, on the curve OA, both solid and gas will exist in the thermal equilibrium. So what the OA curve will represent? What OA curve will represent? What OA curve will represent? So OA, solid and gas state exists in the thermal equilibrium means OA is the sublimation curve. OA is the sublimation curve. So what I said, second type of question means they can ask they will ask which OA represent which curve, OB represent which curve. So OA is the sublimation curve. OA is the sublimation curve. This everybody got? Why solid and gas exist in the thermal equilibrium on the OA? If you see the OB, one side of the OB is the liquid, one side of the OB is the solid. Okay, and on the OB, it means both solid and liquid state exists in the thermal equilibrium. So what is the curve OB? OB is the melting curve. OB is the melting curve. This everybody got? Okay. Now if you see the OC, one side is a liquid, one side is a gas. Okay, one side liquid, one side gas. Then it means on the OC, liquid and gas exist in thermal equilibrium. Liquid and gas exist in thermal equilibrium. So OC, what we can say? OC is the not the boiling, it is a vaporization curve, because 0.01 degrees say not boiling, that I said, Mokshika. Because 0.01 degrees C, water will not boil, na? And but I said what? Evaporation take place at all temperature. Okay, so it is a vaporization, not the boiling. Boiling means it will be somewhere here, 100 degrees C somewhere here. Okay, so it is a vaporization curve. So one type of problem is this. Completed. Okay, so O and O represent what? O represent the at O. All the three curves are meeting at O. All the three curves are not boiling point. It is a vaporization. At the O, all the three curves are meeting. All the three curves are meeting means all the three states are meeting. So that O represent what? Triple point. O represent the triple point. So O triple point, OA is the sublimation curve. It is a sublimation curve. And then OB and OC, OB is the melting and OC is the vaporization. It is a melting and it is a what? Vaporization curve. Completed? Okay, so this is the second type of question what they can ask in this graph. Okay, O triple point, OA sublimation curve, OB melting curve, OC vaporization curve. Next third type of problem what they can ask. Suppose I am saying water is at the triple point. Water is at triple point. Okay, means we have the triple point state that is at O. Now we are maintaining the temperature constant, pressure increases. While maintaining the temperature constant, pressure increases. Then who will say which state we will have, which state of water we will have? Again, I am repeating. First, water is at the O. We have the we are at the position O or state O. Now, maintaining the temperature constant, pressure increases. Which state we will have? Maintaining the temperature constant, pressure increases. Maintaining the temperature constant, pressure increases. Which state we will have? Liquid state. So one thing, remember that in whole thermodynamics, most of the places we will use, when we have to plot the graph, different graph, different chapter you will get the graph. When we have to plot the graph and any quantity is constant, any physical quantity is constant. Okay. So which quantity is constant? If we are taking that quantity on the either x-axis or y-axis. So which quantity is constant? Graph will be straight line perpendicular to that axis. Graph will be straight line perpendicular to that axis. Again, I am repeating. Which quantity is constant? If that quantity we are plotting either on x-axis or y-axis. So which quantity is constant? Graph will be straight line perpendicular to its axis. Perpendicular to its axis. Like acceleration and velocity graph. Suppose I am plotting acceleration, velocity graph I am plotting, and I am saying acceleration is constant. Then I will make the line straight line perpendicular to acceleration axis. Okay. Suppose velocity time graph I am plotting and I am saying velocity is constant. Then I will make the straight line perpendicular to the velocity. In thermodynamics, suppose I am plotting the volume and temperature graph and I am saying volume is constant. Then I will draw the line perpendicular to the volume axis. So which quantity is constant? Graph will be straight line perpendicular to that axis. Okay. Now here what I am saying, while maintaining water is at the O, Okay, and we are maintaining the temperature constant but pressure increase. Temperature constant means we will draw the line perpendicular to temperature. Okay, and water is at O means I will draw the line like this. Okay, so on this line temperature is constant. Okay, because I am saying water is at the O. Now it is at the O, temperature constant, pressure increase. I will go up. When we will go up, then we will have only liquid state. We will have only liquid state. So water is at the O. Now maintaining the temperature constant, pressure increases. Which state we will have? Which state we will have? Liquid state. Everybody got? Okay. Completed. If I am decreasing while maintaining the temperature constant, decreasing the pressure, then which state we will have? While maintaining the temperature constant, decreasing the pressure, which state we will have? Decreasing the pressure, then we will have gas. Okay, are everybody getting? Increasing the pressure, liquid. Maintaining the temperature constant and water is at O. I increase the pressure, I reach up, then liquid. I decrease the pressure, gas. Everybody got? Okay. So you'll remember this example? Okay. Same, suppose I am saying, I am maintaining the pressure constant. Pressure constant means I will draw the line perpendicular to the pressure. Now temperature increase. Water is at O and maintaining the pressure constant, temperature increase. Which state we will have? Maintaining the pressure constant, temperature increase. Which state we will have? Which state I am saying? Gas state. Yes, we will have water is at O. Now I am maintaining the pressure constant means this line. I am increasing temperature, I will go right. Right means which states? Gas. Decrease the temperature, solid. Everybody got? Decrease the temperature, then solid. Like that, one type of question they can ask this. Up to this, everybody got? Okay. Now listen carefully. So state completed. If I am saying water is at O, next type of problem. If suppose I am saying water is at O, now I maintain the temperature constant and I increase the pressure. Now I am saying which state will occur or which process will be favorable or which process will be favorable or which process will occur. I repeat again, water is at O, I maintain the temperature constant, pressure increase. Then which process will carried out? Which process will occur? Water is at the triple point. Now maintaining the temperature constant, pressure increased. Then which process will occur? Or which process will be favorable? Okay, somebody is saying vaporize. No process occur, is only liquid, sir. Okay, one answer. Somebody is saying melting. Somebody is saying vaporization. Somebody is saying no process. Okay. Now listen. One thing first, for this type of problem, first we have to decide the state. If I am saying water is at O, temperature I maintain constant and I increase the pressure, which state we will have? Then we will have only liquid state. This everybody got or not? We will have only liquid state. Little fast. Which state we will have? Liquid state only. At O what I have? At O what we have? At O, what we have? At O, what we have? At O, we have all the three. That is the definition of the triple point. So at O, we have all the three. At O we have all the three. It is a triple point now. So at O we have all the three. Okay. Now I maintain the temperature constant, pressure I increase, then what I have now? Only liquid. Only liquid. It means at O I have all the three. After increasing the pressure, I have only liquid. It means at O I have solid, liquid, gas. Now after increasing the pressure at constant temperature, I have only liquid. It means solid convert into the liquid. Gas convert into the liquid. Liquid already liquid, no problem. So solid convert into the liquid, melting. Gas convert into the liquid, condensation. It means two process will be there. Okay, because whole triple point means all the three state we have. It convert into the only liquid. It means solid convert into the liquid, gas convert into the liquid, liquid already liquid. Okay, so how many process? Two process. One is the melting, one is the vaporization, condensation. Everybody got? So state, if I'm asking, so state will be only one. State will be only one. But if I'm saying process, then process will be two if the water is at the triple point. Are say yes or no? Same way, suppose everybody understood or not? Same way, suppose I am saying I am maintaining the pressure constant. What here we are at O and we are maintaining the pressure constant. Temperature increases. Temperature increases. Which process will occur? While maintaining the pressure constant, temperature increases. Which process? Maintaining the pressure constant, temperature increases. Which process? A little fast. So state will be gas only. State will have gas only. State is the gas, but solid convert into the gas, liquid convert into the gas, gas to gas, no problem. Solid to the gas, solid to the gas, sublimation. Liquid to the gas, vaporization. So sublimation and vaporization. Okay, everybody understood, I think now. So this example, what we can say? Solid to liquid and gas to liquid. Okay, because finally we have, so this will be what? Melting, and this will be gas to the liquid means condensation. Okay, so two process. Two process, one state. Two process, one state. Okay. Completed. Okay. So one process they given in the NCERT, and one more graph. First thing is one more graph they given for the triple point in the NCERT. Two triple point curve given. One they given for the CO2. So that also I am just making here for CO2 triple point curve. Okay, so similar curve has given like this. Here we can say what? Liquid, here is the gas, here is the solid, and the temperature is around minus 56.6 degrees C. Okay, so but that is not much important. So two triple point curve given in the NCERT, one for the CO2, one for the water. CO2 is also similar like water. Here we are getting the liquid state, this side gas, this side solid, and temperature is the minus 56.6 and pressure is around 5 atm. Okay. One process explained in the NCERT in the one paragraph. Okay. Regulation. Okay. Regulation. Anybody know what is a regulation? What is a regulation? Anybody will say? So listen. Sir, then every move from O gives two process. Yes, Vardhan. Two process will be there. Yes. So listen, regulation is what? Now listen, we know that, and from the triple point graph also we can say, already I said in the thermometry also, on increasing the pressure, boiling point increases, boiling point of water increases on increasing the pressure, and on increasing the pressure, melting point decreases, boiling point increases. This everybody know or not? So on increasing the temperature, on increasing the pressure, boiling point increases, and on increasing the pressure, melting point decreases. If you want to see from the graph also, we can get. So melting point means here it is a 0.01 degree C. So 100 degree C will be somewhere here. Okay. This is the 100 degree C. Now suppose I increase the, and here pressure is this. Suppose I increase the pressure, I will shift. This is a graph. If I increase the pressure, then I will shift up. If this point will shift up, so this temperature will go to the right. Otherwise, separate figure I am making. Suppose this is the graph. Here suppose I am saying 100 degrees C. Okay, this is the boiling point, and this pressure is the 1 atm. Okay. Now when I will increase the pressure, the point will shift to the right. You can see pressure increase, this will shift to the right. It means on increasing the pressure, boiling point increases. Boiling point increases because on increasing the pressure, if I increase the pressure, will go up. This point will go to the right. But for melting point, here it is a 0.01. So somewhere here we will have 0 degree C. Okay. Now this is the pressure. If I said, if I increase the pressure, it means I will go up. So this point will go to the left. This point will go to the left. It means on increasing the pressure, melting point decreases. So from the graph also we can see. Everybody got? And this already I said, on increasing the pressure, boiling point of water increases and the melting point decreases. So what is the regulation? Regulation means, one example, suppose we have the one large ice block. Regulation numerical is not there, but at least maybe suppose in the matrix match they ask like which process is this regulation they given. So at least you have to know what is the meaning of the regulation. Okay. So suppose I have the one big ice block. In that put the thread. Okay. Hang the thread. And the other two end just suspend the mass. Okay. So when you suspend the mass, what will happen? This mass will produce the tension in the rope, and due to that tension on the ice, it will apply the force on the ice. Force means I can say the pressure. So again I am repeating, ice block, big ice block, you put the thread on that, okay, and from the other two end you suspend some mass, okay. Then due to the mass or weight, what will happen? It will have the tension, so it will apply the force on the ice block, okay. Like you are pushing the ice block with a knife, means you are applying the force or pressure on the ice block. So what will happen due to this thread? Below the thread, what will happen? Pressure will be more. Why? Because the weight or tension is there. Due to that, on the ice, pressure will be there. Pressure will increase. Okay. Above the thread, pressure is the atmospheric pressure. Above the thread, pressure is atmospheric. We know that on increasing the pressure, melting point decreases, means ice will melt at negative temperature. So when you press it, like due to the pressure, below the thread, pressure more. Pressure more, melting point will be lesser. Melting point will decrease. It means below the thread, water will melt at negative temperature. Okay. Water melt, thread penetrated the ice block. Okay. So when the thread penetrated the ice block, water will come up of the thread. Okay. So thread goes in, water comes up. When the water will come up, now above the thread pressure is the atmospheric. Atmospheric pressure, freezing point is 0 degree C. So negative water, it will get freeze at 0 degree C, because due to the surrounding heat, its temperature will rise and it will reach to the 0. It will again get freeze. Okay. So first what you did, you put the thread on the ice block. Then due to the pressure, Below the thread, pressure increases, melting point decreases. Melting point decreases, it means what will happen? It will melt at negative temperature. When the ice melt, thread penetrated, then water comes up, then now due to the surrounding heat, its temperature will increase, and when it will reach to the zero, again it will become ice. It will convert into the ice, because above the thread pressure is the atmospheric, but below the thread pressure is more. Like that way, thread is penetrating, thread is going in. As the thread is going in, water is coming up, and due to the atmospheric heat, it is getting converted to the ice. So as thread is going down, penetrating, and upward water is freezing. When the thread will cross the whole ice block, then ice block will not get cut into the two equal part, because the thread has passed the ice block, it has to cut to the two equal part, but it will not cut. Why? As it was going down, above water was freezing. So thread will cross the ice block without cutting the ice block. Okay, so this process, now what is happening here? Water is getting freeze. Above water pressure is atmospheric. Again it is getting freeze. So what is the regulation? Not a freezing. Refreezing of the water, or refreezing of the ice. Due to the change in pressure. That we can call regulation. Okay. Sorry. So what I said, just you have to know that definition. That is called the regulation. Okay. One last graph I am saying, that is given in thermodynamics, but here I said, that's why just you have to remember. Okay, so I said what specific heat of the substance, specific heat value depends upon the substance. For the given substance, it is constant. But what I said, any quantity depends upon the material. So material property changes with the change in temperature. So if they are asking which graph shows the variation of the specific heat with the temperature, so basically it is given for the water. But by this we can say the water specific heat is not constant throughout. Okay, variation is small, like between the 1.008 to the 0.996. Variation is not very large, but by this we can say specific heat is not constant, it changes with a change in temperature. Everybody got? Completed? Okay. Now this chapter, almost like this chapter is over. So next we have to start the heat transfer. In the heat transfer beginning, some definitions are there. Okay. So for the definition may be possible, first I will explain all the definition, but you will take time to write. Then maybe I will send some one page of the printed note. Otherwise here in fast I will write. Okay. Those definition you have to know to learn the other like formula and to do the numericals. Okay, so I will start next. Now you can complete the whole calorimetry. Okay, whatever the problem you are getting, you can solve, but no need to waste more time in that, because very difficult question is less chances there in the calorimetry they will ask. Okay. Completed. So mode of like heat transfer, everybody know the mode of heat transfer. We know that three mode of heat transfer. Three mode of heat transfer is what? Conduction, convection, and radiation. Okay. Convection, no numerical is there. Convection only we have to know the definition and some other theoretical question. Radiation already deleted, but few things we have to know in the radiation also. So conduction, convection, radiation. Radiation is the fastest mode of the heat transfer. Radiation, because it is an electromagnetic wave. Radiation is the electromagnetic wave. So that's why it is the fastest mode of heat transfer. Because we can say it travels with the speed 3 into 10 to the power 8. Even it can travel in a vacuum also. Okay. So radiation, maybe medium is there or not there, but radiation can travel. Okay. Because it is an electromagnetic wave. So radiation is the fastest mode of heat transfer. Okay. This everybody got. So like when you fire and then immediately when you put your hand above, immediately you will feel heat. So conduction air is a bad conductor. It will take more time to conduct. Okay. Convection heat will also take time to get set. But immediately as the fire you put your hand above, then you are feeling the heat. Due to which heat? Radiation. Okay. So radiation is the fastest mode. It can travel even without medium. Convection is only possible in liquid and gas. Convection is not possible in solid. Why? In convection, hot molecules move from one place to another place. Cold molecule will move from one place to another place. Means heat flows due to the movement of molecule from one place to the other place. That is not possible in the case of solid, because in the solid molecules cannot or atoms cannot move from one place to the other place. So convection is only possible in the liquid and gases. Like when you are heating the water in the container, you can see also from the bottom you will see bubbles started rising. As the bubble rise, some water drop will go down, they will get heat. Like that way molecules are moving, and after some time whole water will get heated. So in the convection, heat take place due to the transfer of the molecule from one place to the other place. Okay, that is not possible in the solid. That's why convection is only possible in liquid and gases. This everybody got. And conduction is what? In that molecule does not transfer by the vibration, because everything in the universe is vibrating. So by the vibration they transfer the energy to the next, like that. So here in the conduction, molecule or atom does not transfer permanently. By the vibration only they are transferring the energy. So that's why in solid conduction is prominent in solid, we can say, because in the solid molecules cannot go from one place to the other place. Everybody got? So conduction, that is a prominent in the solid. Convection is only possible in the liquid and gas. Radiation, it can even with the travel without medium also, and it is the fastest mode of heat transfer. Okay. Why no class was Monday? Monday there was an exam, no? Monday there was a space exam. That's why there was no class. Okay. So these are the things. Like I will send some notes you want. Then I will send the notes also. It is written all. Okay, in the class notes I will take the picture. But this everybody has to know, and some definition also I will say in the next class. Okay. Then we will start the problems and numericals. Okay. Okay. Then bye bye. Okay, I will send in the app, no problem. Bye. Off.
Now let's